Hi guys, in today's video, I'm going to be discussing parametric equations. I'm going to be continuing with the AP Calculus BC syllabus. So the first formula I'm going to give you is the formula for the slope. So we know that the slope is dy by dx. And in parametric, it's written as dy by dt over dx by dt. So this is the slope in parametric equation. And now what do we have to find the second derivative, d squared y over dx squared? That would be d by dt of dy by dx. And we know what dy by dx is, divided by dx by dt. So the numerator is basically us deriving the first derivative, and that divided by dx by dt. So these are the two formulas we should know. So let's see one question. So they've given us that x is equal to t squared plus 9, y is equal to 4t to the power of 5 minus 6t cubed plus 3. We have to find dy by dx and d square y over dx squared in terms of t. So we just apply the two formulas which we learned. So let's first find what dx by dt is. That would be the derivative of x, which is 2t. dy by dt is the derivative of y, which is 20t to the power of 4 minus 18t squared. And now we can find dy by dx. dy by dx is dy by dt, so 20t to the power of 4 minus 18t squared over dx by dt, which is 2t. This can be written as 10t cubed minus 9t. This is done as we can factor out 2t from the numerator and then cancel it out from the denominator. So we're left with 10t cubed minus 9t. Now let's look at how to find the second derivative, d squared y over dx squared. So we know that that is the derivative of dy by dx. So the derivative of, so d by dt of dy by dx, which is 10t cubed minus 9t over dx by dt, which is 2t. This can be written as 30t squared minus 9 over 2t. And this is our second derivative. So now we have found what dy by dx and d squared y by dx squared is. So that's how easy it is, and we just have to know how to apply these two formulas. Let's look at one more question. So if they've given us x is equal to 5 sine t and y is equal to 3 cosine t, you have to find the equation of the tangent. So you have to find the equation of tangent at t is equal to 2 pi over 3. So find the equation of the tangent at that t value. So let's go about solving it the same way. Let's first find what dy by dx is. For that, we need dx by dt, which is the derivative of 5 sine t, which is 5 cosine t. And dy by dt is the derivative of 3 cosine t, which is negative 3 sine t. Now, dy by dx would be dy by dt, which is negative 3 sine t, over dx by dt, which is 5 cosine t. And we know that sine t over cosine t would be the tangent or tan t. So we know that dy by dx is negative 3/5 tan t. So now let's find the value of dy by dx at t equals 2 pi over 3. So dy by dx is equal to negative 3 by 5 tan 2 pi over 3, which is 3 root 3 over 5, or 3 over 5 root. So this is what our value of dy by dx is. Now, for the equation of the tangent, we need a point x comma y. And we know that we have to find this point at t equals 2 pi by 3. So at t equals 2 pi by 3, what is x and what is y? We can just substitute it into our value of our equation for x, which they've given us in the question. So x is equal to 5 sine 2 pi over 3, and y is equal to 3 cosine 2 pi over 3. And now this would be equal to 5 root 3 over 2, and y would be equal to negative 3 over 2. Now that we know the value of x, y, and the derivative, we can use point slope form. So y plus 3 over 2 is equal to 3 root 3 over 5 times x minus 5 root 3 over 2. So this is our equation of the tangent at t is equal to 2 pi over 3. So that's how easy it is. Okay, that's it for today's video, guys. In today's video, I introduced two formulas for parametric equations and discussed two questions on it. Thank you, and I hope you all have a great day, and please consider liking and subscribing.